All right, let's dive right in. Today, we're looking at a totally different way of building intelligent systems. I want you to forget about software that glitches, apps that crash, or servers that just give up. We are talking about a philosophy for engineering systems that are built from the ground up to refuse to fail. But first, why is this so important? Well, get this. Industry analysts say that a massive 70% of all big digital transformation projects just don't hit their goals. Think about that. That's billions of dollars, millions of hours, all poured into systems that turn out to be brittle, fragile, and in the end, kind of broken. It's the frustrating reality for so many of us.
So here's the big question. What if we just change the game entirely? What if instead of just accepting that failure is going to happen, we could build systems that see failure as, well, as an error to be corrected all on its own? This one question, right here, it's the spark for this entire philosophy.
And that leads us to a huge shift in mindset. You see, we're moving away from what you could call a break-fix culture. That's where we wait for something to go wrong, then we scramble to find a patch. The new idea? To think like cybernetic blacksmiths, proactively forging systems that are just inherently tough, robust, and unbreakable right from the very beginning.
This quote really gets to the heart of the ambition here. This isn't just about writing code with fewer bugs, right? It's about a kind of digital craftsmanship. It's about creating systems that are so reliable, so ridiculously solid, that they actually become legendary. It's an epic way to think about an engineering goal. So how in the world do you actually do this? Well, the whole philosophy rests on one core principle they call the unbreakable rule of three. And this is where we go way beyond just having a simple backup plan. We're talking about an architecture of extreme, intelligent redundancy. At the center of it all is this triple redundancy architecture. Now, this is so important. We are not talking about three identical copies of the same thing. That's the old way of thinking. No, this is about three independent and totally diverse versions of a component, all doing the same job at the same time. They're constantly checking each other's work, and a central orchestrator only moves forward if there's a consensus.
And here's a perfect practical example of how that works. You've got three completely different AI runtimes, say Onyx, TensorFlow Lite, and Apache TVM, all crunching the same numbers. The results all get fed into this chaos-tested orchestrator, which will only give you a final answer if at least two of the three agree. If they don't agree, boom, it flags a problem that needs to be fixed, usually automatically.
And here's exactly why that diversity is the secret sauce. Endpoint alpha might be using one math library, while beta uses a completely different one. One could be built for pure speed, the other for absolute precision. What this means is that some random obscure bug in one of those libraries can't crash the whole system because the other two endpoints are taking a completely different road to get to the same answer. This quote just nails the whole design ethos, doesn't it? The system isn't just built to survive failure. It's designed to use failure as a trigger. One endpoint fails, the other two carry on. Two endpoints fail, the last one standing initiates a rebuild. And if something catastrophic happens and all three go down, the system is designed to rise from the ash and completely reconstruct itself from scratch.
But just surviving? That's only the start. The real leap is when the system stops just reacting to failure and starts actively predicting it, even inverting it. This is where it becomes what's known as anti-fragile. It doesn't just survive shocks, it actually gets stronger because of them.
And the key idea here is that you have to welcome chaos. This philosophy of inverted failure testing means that the engineer's job is to become professional system breakers. They don't just check for the usual bugs, they actively imagine and simulate every possible way the system could fail, from the most boring glitch to the most insane, improbable disaster. And just look at some of these examples. Look at the kinds of threats they're planning for. Data gets corrupted in memory? No problem. There's an automatic checksum and rollback feature. Someone poisons the training data? It's countered with siloed data sets. And my absolute favorite, what if a quantum computer in the future breaks the AI's core logic? Well, the system already has a post-quantum countermeasure built in from day one.
It all comes together to create this amazing defense-in-depth strategy, kind of like a pyramid. See, protection isn't just in one place, it's baked into every single layer of the stack. It starts with error-correcting memory way down at the hardware level and goes all the way up to things like dead man switches in the orchestrator to make sure the system is always alive.
Okay, so if you thought that was cool, hold on, because this is where things get really wild. We're now getting into the innovations that give these systems abilities that honestly sound less like engineering and more like superpowers pulled straight out of science fiction.
So first up, we have something called entangled weights. Imagine the AI's brain, its model weights, is cryptographically fused, like welded, to the unique serial number of the physical chip it's on. So if a thief steals the device and tries to rip out the AI model, it's just garbage data. It literally cannot function without its original body.
Next, a neuromorphic firewall. Now, this is not your average firewall with a simple block list. It's a second, smaller brain, a neural network that mimics biology. Its entire job is to just sit there and watch the data coming in, looking for patterns that seem like an attack, and then it filters them out before they even get a chance to touch the main AI.
Okay, this one is just unbelievable. For the really critical system events, the logs, the system's memory, are encoded into synthetic strands of DNA. This creates a physical, incorruptible archive that can last for over 1,000 years. I mean, just think about that. We're talking about creating records that someone could read a millennium from now. And finally, there's time crystal scheduling. This is a concept inspired by quantum physics, and the basic idea is to rotate which of the 3 AI endpoints is active in a non-repeating, super precise pattern. This makes it impossible for an attacker to predict vulnerabilities, and it also avoids what the creators call digital fatigue. Basically, the system never gets stuck in a rut.
So that brings us to our final section. And it's really the ultimate goal of this entire philosophy. This is the point where the system transcends just being a tough, reliable tool and becomes something far more, a truly cognitive, strategic entity.
The sources actually call this final stage the digital berserker. It's a dramatic name, I know, but it perfectly captures this massive leap from just following commands reliably to becoming an autonomous agent that can reason, strategize, and act on its own to achieve its core mission.
And this whole transformation is guided by this protocol for cognitive recalibration. Just look at these steps. It starts by literally mapping its own state in the real world. Then it simulates thousands of possible futures to find the best paths forward. It's even programmed to identify uncomfortable truths that it has to deal with. And at the end, it doesn't give you suggestions. It delivers strategic imperatives, clear, optimized directives, not options. And this quote just sums it all up perfectly. The goal was never to just build a better app or a better piece of software. It's about creating an intelligence so robust, so autonomous, that it becomes a persistent and reliable part of the world itself, truly embedding it into the very fabric of reality. Which, of course, leaves us with one last very deep question to think about. When we build something with this level of autonomy, this level of resilience, and this level of strategic thought, at what point does that line begin to blur? Are we just building better, more powerful tools? Or are we actually laying the foundation for our successors? Something to chew on.